You're listening to STEMxm, where women in science, technology, engineering, and mathematics share their stories of success, overcoming barriers, and breaking the glass ceiling. And now, your host, Mel the Engineer.
Hello, and thank you so much for joining me today for episode 20 of the STEMxm podcast. I am your host, Mel the Engineer, and I'm really excited to bring you the fourth episode today in a series on water and wastewater careers. So the first few that we had, they focused on different aspects of domestic wastewater treatment. And then in this previous one, episode 19, we spoke with an engineer about drinking water treatment. So today we have Bethany Bezak with us, and her expertise is in green infrastructure. So she focuses on stormwater. So this is a really interesting area that I think people may not hear about this really regularly. So it's going to be fun to hear how Bethany found this niche and why she's so passionate about it. Okay, so Bethany has a bachelor's degree in civil engineering from Lawrence Technological University, and she has a master's degree in biological or biosystems engineering from Virginia Tech. And she currently works as a green infrastructure manager and planning coordinator for DC Water. So big responsibility and really cool work. Okay, so we're going to jump right into our chat with Bethany, and then I'll be back on with you at the end to talk about show notes and our upcoming final episodes for the water and wastewater series, and we'll chat about that. All right, and here we go. Hello, Bethany Bezak. Thank you so much for joining us today on STEMxm.
Hello, how are you?
I'm doing just fine. So I would like to start with some questions about your childhood. Can you tell us, where did you grow up?
Sure. I grew up in Milford, Michigan, which is a suburb outside of Detroit, Michigan. I grew up in a fairly rural area, and we had a lot of open space, a lot of time outdoors, and I think that's really something that really stuck with me as I started to grow up, and something that I really wanted to carry on through my career.
Okay, very interesting. So my next question to you is going to be, when you were young, were there any particular subjects in STEM that you were fascinated by? And maybe does, this love you have for the outdoors kind of play into that?
Definitely. I mean, math and science really have always stuck with me. I really was a very analytical thinker fairly on in my childhood. I liked order. I liked process. I liked things to be very organized. And so, math really was something that was very interesting to me. And then any of the physical sciences as well. So biology, chemistry, all of those were very interesting to me.
So when you were in high school, did you know what you wanted to do next? Like in college, how did you decide, where to go to university and what to study there initially?
Sure. So in high school, again, math and science were very interesting. And so I just knew that engineering was probably a pretty natural fit for me. And as far as going into a specific engineering field, I figured out that civil engineering was of interest because it allowed me to get outdoors. It allowed me to really apply math and science principles to the real world.
Well, tell us a little bit more about that, because you said you knew it would be kind of natural for you to go into engineering. But I think for a lot of people, if they don't know an engineer and what an engineer does, like that would not necessarily be the conclusion they would come to. So can you tell us more about that? Was there someone around, or maybe multiple people, that influenced you?
Sure. So my dad certainly had a background in technical fields. He studied architecture. And then I also had an aunt who was in mechanical engineering as well. And I think just having some of those influences in my life drew me to those fields. I was able to understand what it was in a typical day to be an engineer or be in a technical field. And I think that helped shape, my love, I think, of sciences, and seeing that there was a practical application that I could pursue as a profession.
Okay, great. So you're at university and you've decided to study civil engineering. Did you take any classes that really stood out to you that you really loved that influenced your path?
Within civil engineering, I had always been fascinated with water. The idea that it's a very natural process, that water is always flowing. And streams was something that really resonated with me. It's kind of like a living feature, if you will, in our environment. And I really just always felt like that was pretty fascinating. So in college, I took a stream restoration class, which is basically the study of how streams move and how they form through the earth, essentially. And so I learned about how streams actually interact with nature and how we needed to restore and protect them in an urban environment. And that was something that was just very interesting to me. And after taking that class, I knew pretty quickly after my undergrad degree in civil engineering that I wanted to pursue a master's as well to understand that a little bit further.
Okay, so did you go straight from undergrad to this master's work?
No, I did spend a few months working between my undergrad and my master's, and I did feel like that was a very positive experience because it helped me understand what it was to really work day to day in the engineering field, and it helped me solidify my interest in wanting to pursue an additional degree after my undergrad. I really wanted to learn a lot more about a specific topic, and so that's what really helped me decide to go back and get my master's.
And this work that you mentioned, was that like an internship?
No, it was a full-time engineering position. It was a company out of near Pittsburgh where I worked on a dam and reservoir projects.
Okay, so how did you find that position to begin with?
Well, just out of college, my husband was living in Ohio, and he was working at the time, and so that focused my efforts on moving into that area. And then it was just happened to come through, and it was of interest to me, and so I took that right out of my undergrad degree.
Okay, very cool. So you're in DC now. So walk us through the next steps that happened for you in your career. You went back for a master's degree in something slightly different. Well, maybe we should start with that. So your master's degree, talk to us about that specialty and what it was like to go from engineering to this other area.
Sure. So I pursued a master's degree in biological systems engineering at Virginia Tech. And the reason I was interested in that degree was it was a specialization from civil engineering. It's a bit more of an environmental focus compared to a traditional civil engineering degree. And I specialized specifically on streams within my master's program. And so after I got that degree, I continued to have a real strong love and interest in sustainability related topics, specifically related to civil engineering. So groundwork, earthwork, restoration of construction sites, restorations of wetlands, of streams. And so after my master's, then I had several job opportunities across the US, and I pursued a full-time position as an engineer at Wetland Studies and Solutions.
If I could have you describe that a little bit more. So you mentioned restoration, like at construction sites when they're done putting in whatever it is they're building. Could you describe for us how that's actually accomplished? Like, how do you come up with a plan for that, and then how is it implemented?
Sure. So typically when construction takes place on any construction site in the United States, there are some type of regulations that need to be followed in terms of ensuring that there's some type of protection of the environment. And so typically there will be some type of regulating entity that will require that some type of restoration activity takes place after a construction activity is implemented. So, let's say a building is going up, whether that be a commercial building or a residential home. And if there is an impact, let's say to a stream or a wetland or some natural resource feature on that site, then typically you're required to somehow mitigate or somehow protect that site to make sure that we're not doing any additional harm to the environment. And so that was a lot of the focus of some of my early work as an engineer.
Okay, so say, just for an example that, a big bridge is built and it's impacted a stream. What would you do to mitigate the impacts that, this new structure or bridge has created? Is it just I'm trying to visualize it. Is it just a matter of rerouting it?
Sometimes it's merely just protecting the stream in place to make sure that it doesn't get damaged. Sometimes it's actually rerouting the stream permanently. Sometimes it's temporarily rerouting the stream. So it really can take a lot of different forms in terms of what the real impacts are based on a construction project.
Have you been able to get involved with any of the, kind of species protection stuff to that, like protecting plants and animals that are in that area?
Sure. So some of the work that I have done has been focused on that, but that's not been my area of specialty. So I've worked on projects where that's been a component of the site, has been restoration or protection of a particular species of plant or animal. Most of the work that I've done has been on the engineering side in terms of actually protecting the stream or redesigning the stream to make it more ecologically friendly or be able to function better.
Okay, and you mentioned earthworks. So I was just wondering, how much does geotechnical type of engineering play into this work?
Well, really quite a bit. Within civil engineering, there are quite a few different specialties that you can go into. So for instance, a structural engineer works on buildings and making sure that they're stable and sound. And then you can have, on the other side of the spectrum, a geotechnical engineer who focuses on the soil and earthwork and making sure that the ground is stable ultimately. And so quite a bit of what we do as civil engineers has to do with something related to groundwork or earthwork, making sure that when you move soil that you're putting it back appropriately, making sure that it's compacted so it's stable after something is constructed. So almost anything really in the built environment has something to do with the geotechnical or earthwork.
Okay, very cool. All right, so going back to kind of your path, so walk us through what you did after you earned your master's degree.
So after I earned my master's degree, again, I started working as an engineer, a staff level engineer at a small engineering firm out of Washington, D.C. called Wetland Studies and Solutions. And they focus on the sustainable elements of construction sites. So whether that is, again, protecting species, whether that's plants or animals or invasive species control, or whether that's protecting streams or restoring streams or wetlands. So it really was the full spectrum of things that I worked on when I was at Wetland Studies. And one area of specialty that I focused on was sustainable engineering. And so over the past 15 years or so, there's been definitely an interest US wide in building sustainably. And, that can mean a lot of different things. That can mean using local building materials. That can mean reusing or reducing water or waste on a site. And so I focused a lot on the water aspects of a site and how we can conserve water and resources and how we can conserve the natural resources on a site.
I think I just want to ask here, if you could talk about that a little bit more. I have a friend working for the EPA that's in a department where they're looking at ways to reuse materials from a construction site. So I wonder if you just might describe this some of the ways that sustainability can be implemented in the construction process, because I think for somebody who hasn't seen it happen, including me, sometimes you just see a big construction site and you think, man, that's like really impactful, and you see a lot of waste that comes from it, different construction materials and whatnot. It's hard to imagine how that can be made sustainable.
There's a lot of material that goes into a construction process. There's a lot of fuel that's used in the construction process to actually power the equipment. There's a lot of material that's actually delivered to the site and used to build a structure or build a construction site. And so the idea of, principle called, rather than cradle to grave, cradle to cradle is the idea here. And that basically what you're trying to do is bring us back full circle in terms of any material that you are creating, you're fully utilizing rather than sending some of that waste stream to a landfill. So it's not the idea that we use things and then we throw them away. We actually use things and then we repurpose them into other products. And so that idea, that principle has definitely been brought, I think, into the construction industry over the past several years. It's certainly an idea that I think is well-founded in the sustainability realm and in efforts to, really think long-term and ecologically about how we can be sustainable with our culture and with our environment.
This is the STEMxm podcast with Mel the engineer.
So you're with a municipality now. Is this the next job that you took after wetland studies and solutions?
It was. So I worked as a consultant for DC Water prior to joining DC Water full time. And going from a typical consulting job where on a day-to-day basis you're working on multiple different projects, it was really rewarding for me to come to DC Water and be able to focus on a single project with a much larger scale and a longer term. And so that's been something that's been very interesting with my work at DC Water.
Okay, so kind of an aside question, has it been important for you to get your professional license through this?
It has, definitely. So after my undergrad degree, I knew pretty quickly that gaining my professional licensure was pretty important. It allows you the ability to actually stamp and seal construction drawings. And so that was definitely the next step after obtaining my undergrad and my master's degree, was to pursue the professional engineering licensure.
Okay, so you're with DC Water. Have you worked your way up? You're in this role now where I think your title is something like Green Infrastructure Manager. So how did this unfold for you?
With my specialty, in the sustainable environment realm, as I said, I mentioned I worked as a consultant with DC Water, and then eventually I moved over to be a full-time employee at DC Water. There was a position that opened up within the green infrastructure department, essentially at DC Water. And it was with the DC Clean Rivers project. And, I mentioned that was something that was really interesting to me because it's a project that has a really long-term focus on improving the environment in DC. And so a position to open up, and I applied to it, and I was fortunate enough to become part of the DC Water team. And in working through that position, I was a green infrastructure planning coordinator, and I spent a few years doing that. And then ultimately there was a need for a manager for that role, for that department. And so then eventually I moved into that role.
Awesome. So Have there been mentors for you along the way that have helped you develop as a manager and as a leader?
Absolutely. There's been quite a few managers I would say that I've had along the way that have been very influential. And one of the things I learned from them is that taking the time to mentor and to teach other individuals is really important. And I've always gotten that from a lot of the managers that I've worked for. And I really appreciated the opportunity to learn and grow in my position. So I do try to take the time to provide that same thing to others. And I think that that's something that good leaders and good managers do well is they promote other people and they teach other people.
Yep, absolutely. So I kind of want to give a plug right now for DC Water because I've heard a couple different people from DC Water speak, like at WEF Tech, which for our listeners, that's a big conference that's done annually by the Water Environment Federation. So it looks like you've got awesome people there and like it's a really good place to work. And of course, you're awesome too. So would you say that's been your experience there?
Absolutely. Really, DC Water has been a great place to continue my profession, my professional career. DC Water really is on the forefront of many different aspects of the water and wastewater industry. I very much have found that true in terms of the work that I do in green infrastructure. There's a lot of people that are very innovative and forward thinking and really looking to do the best for not just DC Water and our ratepayers in DC, but also for the industry. And I think that when you have leaders who are focused on the bigger picture, the industry, people, the environment, these big picture ideals and goals is really when you kind of have the best product. It's a win-win for DC Water. It's a win for the people in the District of Columbia, and it's a win for the environment. And that's kind of the exciting part about working at DC Water is everyone is doing such interesting things within each of their individual fields.
Just out of curiosity, have you ever had to do any of the citizen facing type meetings, like where you've got to go and talk to the people about, what DC Water is doing and why?
Definitely. That's a pretty big part of my role right now is the interface with stakeholders.
Oh, cool.
And when I say stakeholders, I mean anyone from the people that you're talking about, the ratepayers or citizens who are in DC. When we have to go to a commission meeting, that's certainly a big role that I play, all the way through to stakeholders like other agencies in DC, whether that's the Department of Transportation or the Department of Energy and the Environment. We do really have quite a bit of interface with lots of different stakeholders. And that's a pretty big part of my job right now is making sure that we're describing accurately what it is that we're doing. So we really need to help describe the purpose and the mission that we have at DC Water and help people understand how they can be part of the solution to also help the environment.
That's very cool. So I just want to say that this has come up several times with other engineers that I've interviewed where they're working on this really cool stuff, and there's also this important communications piece to it. So for students who are thinking about going into engineering, or maybe they're already in engineering, I wonder if you might give your thoughts on the importance of good communication, whether that's spoken or written.
Absolutely. I can't really overemphasize this, I would say, is you're absolutely correct that communication is really critical. And it's kind of funny because engineers, I think, traditionally are characterized as not being the best communicators, but really it is so important to be able to run all your numbers and do all of your engineering designs on one side. But you also need to be able to communicate that effectively to whether it's a colleague or whether it's a resident who needs to understand what you're doing, or whether it's a regulator who's ultimately going to sign off on your project and allow you to move forward with the project. It's really critical to be able to convey those messages very clearly. And whether that be in the written form or verbal form, that's just such an important part of engineering.
Yep, Completely agree. Okay, so I want to get into a little bit what you work on now. So tell us, for a listener who maybe has never heard of green infrastructure, tell us what that means, and then maybe what that means to you specifically within the context of DC.
Sure. So I'll start at the very beginning, which is, the hydrologic cycle, basically. So what happens when it rains is water actually, falls from the sky, whether it's rain or whether it's snow, any type of precipitation, and it falls on the ground. And in a natural environment where there's a wooded area, forest, or it's a grassland, it's a meadow, or it's a wetland area, it falls on the ground, and the vast majority of that water actually soaks into the ground. It infiltrates down into the soil. Some of the plants actually uptake the water and use it, and that's a process called evapotranspiration. Some of that water actually recharges the groundwater table well below the depth of the soil and the plants. And very little of that water actually runs off. So actually, sheets off and runs off of the soil and makes its way into streams and rivers. And what happens is when we have an urban environment, when we've built up a city, we've essentially paved over lots of these natural surfaces with something that's impervious or doesn't allow water to infiltrate. So there's a lot more of this water that's running off of all of these surfaces, whether that's roads or buildings or sidewalks. And all of these impervious surfaces create more stormwater. And ultimately, the stormwater has to go somewhere because it's not infiltrating into the ground. It needs to go either into a creek or a river, or it needs to go back into our sewer system. So depending on what type of city you either have a sewer system that goes directly into a river, or you have a sewer system that combines sanitary water and stormwater into a single pipe. And that's called a combined sewer system. And so in DC, we actually have both types of those systems. And the focus of a lot of my work is within the combined sewer system area in DC. We're trying to build green infrastructure practices that try to mimic the natural environment of what would have been in the city before we pave over surfaces. So we're actually building practices called rain gardens or bioretention. We're building things like green roofs. We're building things like permeable pavements. And all of these practices basically allow what would have been an impervious surface that created a lot of runoff to a pervious surface that actually allows water to collect, in the practice to be filtered and cooled. And sometimes it's even reduced because the plants are using some of that water, or the water is actually infiltrating into the soil. And all of these practices are trying to reduce the amount of stormwater that's coming off of all these impervious surfaces that we've built in the city. And so that's really the focus of my work right now, is to lead DC Water's efforts to install green infrastructure in a city.
Okay, just a couple of questions from what you just described. Could you describe for the listeners what a rain garden is and how it works?
Sure. So basically, a rain garden or bioretention area is a depressed landscape feature rather than it being raised up above the ground, which you typically see in a landscaped environment. It's actually depressed into the ground slightly, about 6 inches or so, and it allows water to actually be funneled or directed into that practice. And then the water is directed into that practice, and then there are these layers of different soil and material that are installed below that level, where the water will actually come into the practice. It'll be filtered through a layer of mulch and the plants. Then it'll go into a specialized soil that allows the water to drain fairly quickly. And then it goes through a layer of rock and stone. And so all of these layers together are engineered for all of this water to be funneled into the practice and be infiltrated back into the ground.
Thank you. And then the other thing I wanted to ask was, you mentioned that DC has both like a regular sanitary sewer, and then there are some places where there's a combined sanitary and storm sewer. I was just wondering, are there efforts to separate those? Is there a need to in DC?
That's a great question. So that's definitely one of the ways that you can try to manage the problem of combined sewer overflows is that you can take a sewer that currently manages both the sanitary flow and the stormwater flows, and you can separate those two. So you'll go down a street and you'll actually dig up the area that has that single pipe, and you'll install a second pipe right next to it. And then the dedicated flows would be in one pipe to sanitary flow, and the other pipe would be just to stormwater flows. That's definitely an option of one way that you can address issues of in a city. It is very costly. It's very expensive. It's very disruptive to a city because you literally have to dig up every single sewer pipe and install a second pipe right next to it. And so it can be a tool in very directed areas, but typically it's not done across a large citywide area.
Okay. Yeah, I was just curious about that. All right. So I would like to ask you, what is the most technically challenging project that you've worked on and why?
You know, it's an interesting question because I find that technical projects are actually one of the easier challenges of my job. I think that, you know, usually in engineering, there's usually an answer. You can always run some numbers, you can always get to an answer in terms of the technical aspect of a project. What I find is more challenging in some of the engineering projects that I've had to deal with are bringing together lots of different disciplines and lots of different types of people into a project to make it be successful. And if you're able to do that successfully, it usually turns out to be a better project because you have a lot of different interests and you've got a lot of different input into the project. It usually makes it be a much more creative solution and usually I think more sustainable. So, you know, I haven't really found that there are a lot of technical challenges. It's more of the coordination piece that can be challenging to do it successfully.
Okay. Well, so on that, is there a project like that you could describe for us maybe and tell us, how some of these different disciplines influenced the outcome?
Sure. So with the green infrastructure work that I do, I found that it really requires a lot of different types of people and a lot of different ways of thinking about a problem to make it be successful. And so with green infrastructure, the technical aspects of the hydrology and the hydraulics typically are handled by an engineer who has a background in civil engineering like myself. But then there are other components to green infrastructure to make it be successful. You know, these practices are installed in very dense urban areas. And so it also takes more than just the technical aspect of the project to be successful. It takes someone who has a really good eye for the aesthetics of the project and how it actually looks and making sure that it makes sense within an urban environment. It takes someone who has an eye and a specialty for the safety on the project, making sure that you're building the project so that it meets criteria for lots of different users, making sure that it's safe for pedestrians, making sure that it's safe for vehicles on the street. So you really need quite a diverse group of people, I think, to make it successful. Everyone from engineers to city planners to landscape architects to really make a project as diverse as green infrastructure be successful in a city.
We're speaking to engineer and green infrastructure expert Bethany Bezak from DC Water today. I am Mel the Engineer, and this is episode 20 of the STEMxm podcast. You can listen to this episode again on iTunes, Stitcher, or on the website by visiting this episode's show notes page. Okay, I want to switch gears a little bit and ask a couple of questions about sort of your advice to people. So if you were speaking to a student or even a young professional engineer or scientist, and they have a strong interest in a certain area, like like you did with streams. Do you have any recommendations for how they can basically work towards expertise in that area?
Sure. So I would say, similar to what I did, is I got a fairly general degree at first. And so I went and I pursued a civil engineering degree. I did have a slight specialty in water resources within my civil engineering degree. But I went and I pursued a fairly general degree where I studied lots of different aspects of civil engineering. So I had some transportation classes, I had some geotechnical engineering classes, or the soil aspect of civil engineering. I had some structural classes where I looked at how you design concrete structures and steel structures and rebar in buildings. And then I also had the water resources classes. And I think that it's fairly important to get a pretty broad, wide range of knowledge with your first degree, because it really lets you see what the full spectrum of that degree or that profession can provide to you. And I think it also helps you be a pretty well-rounded professional as well when you have a little bit of knowledge about a lot of different topics. And then I would say, if there's something that really sticks with you when you're going through that process of understanding lots of different topics within a professional area, go after some of those things that are of interest to you. Seek an intern or a co-op experience and pursue that a little bit deeper over a summer, or take an additional course on something that might be of interest to you. And when you find that thing that you're really passionate about, then go after your master's, or go after your first job that has that specialty within that field that you want to get a little bit more knowledge, a little bit more in-depth experience in. And then, something I would also say is find those mentors in your life, find those people who have some knowledge and background in something that you want to pursue. And I think that you'll find that a lot of people are very interested in sharing their knowledge with you. I think people will find that, if you reach out to a professional, a teacher, a mentor, another engineer, just someone in the field who has some of the background that you're looking for, that they'll probably be pretty welcome and open to sharing their knowledge with you and giving you some advice on how to take the next steps.
To add to that, that's what I've found as well, that people often want to help, and usually all it takes is initiating a conversation. People are usually happy to share their expertise and give you some time to help you out. Yeah, I think it's in people's nature. Absolutely. Okay, so let's see. I've just got a couple more questions. What is one thing that you wish people outside of your field know that they often don't? So maybe you've encountered this at stakeholder meetings. Is there something that you wish people understood about, stormwater infrastructure that's often misunderstood?
I think just in general, everyone has their day-to-day lives, and everyone has a focus on what they do every day in terms of their profession. And I think sometimes it is challenging to be able to describe to people kind of the magnitude of the problem of something as basic as a sewer system, because most people don't actually think about how the sewer system functions on a day-to-day basis. Most people don't think about how water is delivered to their house on a day-to-day basis. And so just trying to help people understand, those things that everyone takes for granted really do take a lot of engineering and a lot of maintenance and a lot of work on a day-to-day basis from an agency like DC Water or another utility company to make sure that those services keep running and keep functioning for the city and for neighborhoods. And I think that, a lot of times people take those resources for granted, particularly I think in the water industry. If you think about if you lose power, a lot of people will be, pretty disgruntled to lose power for an evening, but you don't frequently lose water service. But when you do, you also recognize how important water is, and how important stormwater and wastewater are as well. And so it's difficult sometimes to help people understand all the technical challenges and all of the work that goes into keeping a system up and running like that.
Yeah, that's a really good way to say it. So, what would you say is the most rewarding part of your role now at DC Water?
I think the most rewarding thing about my job at DC Water is that I have the opportunity to make an environmental impact that will last generations in DC. And with my job, what we're trying to do is reduce combined sewer overflows going into our waterways. And basically what that means is during large storm events in DC, we'll have untreated sewage that's getting dumped into the rivers, the Potomac River, Rock Creek, in the Anacostia River here in DC. And, that's such an awful thing to think about, is that we have raw sewage going into our rivers when it rains. And I think that the opportunity that we have to make an impact for generations, to clean up the rivers and provide a fishable, swimmable place for people, as well as other critters like the fish and other organisms that live in the rivers, is just a really rewarding thing that not a lot of people have the ability to do within their professions. It's kind of a once in a lifetime opportunity, I think, to work on a large project like the one I'm doing at DC Water. And I find that to be very rewarding, and I'm very lucky to be in the position that I am.
Yeah, that's awesome. Would you like to share with us maybe a professional goal that you have for, the coming years in your career?
I'm not one really for a personal legacy, I would say, but I just want to continue to make the strides that we have in terms of cleaning up the rivers. And the program that I'm working on is a 25-year program. And so I'm always looking to the next year to be able to say, okay, did we meet our milestones? Did we meet our targets? Have we kept our construction on schedule? I'm always looking to the next milestone of the program. And so for me, it's really about the work. It's about achieving the goals of the program, achieving the environmental benefits long-term for our project.
Okay, awesome. So this is my last question. I just kind of want to open it up for you. Do you have any advice either for students or young professional engineers or scientists that you would like to share with them?
I would say, there's a world of opportunities that are open to people. You basically can be anything that you want. I think sometimes that's a challenge because there are too many opportunities and there are too many different choices that you have to make in life. And so I would say, find something that you're passionate about and stick with it and pursue your degree and finish your degree. And don't get too sidetracked with, too many opportunities. It is also equally as important to find something that you love and then pursue it and be able to say that you accomplished your degree and that you're able to move on to something even bigger and better.
That's great advice. Well, Bethany, I want to thank you again for taking time this evening to get on a call with me and join us for the STEMxm podcast. You've been great to chat with, and you have a really interesting career. So thank you so much for taking the time and sharing your path with us.
It's been a pleasure. Thank you.
Thank you so much for joining us today. Bethany really has a unique career, and she manages a very important part of infrastructure that impacts our lives. After all, she and other engineers like her help make sure that our roads don't get flooded when we have heavy rains. And they are also looking forward at mitigating impacts that are to come as climate change becomes more acute. You can check out today's show notes at the usual place, STEMxm.com/episode 20. That's STEMxm.com/episode and then the number 20. Again, this was the 4th episode in the series we're doing on water and wastewater careers. The first few were on wastewater treatment operations, municipal master planning, and drinking water treatment. So you can check those out. They are episodes 17, 18, and 19, respectively. We've got 1, maybe 2 more episodes to come in this series, and the next will be with a very special guest, Tracy Fanara. Dr. Trey, as she sometimes goes by, is a researcher at Mote Marine Laboratory, and she was also on Mythbusters. Super cool lady, so stay tuned for that in episode 21. Thank you again for listening today. It would really mean a lot to me if you would consider sharing the STEMxm podcast with any teachers, students, or young professionals you know who might benefit from the podcast as a resource. Also, I'd love to hear from you, so come on over to our Facebook page or Twitter and drop me a line. The Facebook page is at facebook.com/STEMxm, and we're on Twitter with the handle STEMxm Podcast. That's all for now. I'll catch you in episode 21.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.